Hi, my name is Erin Kara, and I'm an astrophysicist at NASA's Goddard Space Flight Center and the University of Maryland. I was part of a team who used X-rays to map the environment around a recently discovered black hole, learning new details about how those surroundings evolve as material swirls closer to the black hole. We made the breakthrough using observations from NASA's Neutron Star Interior Composition Explorer, or NICER, on the International Space Station. NICER let us watch a flare of light from the area around a black hole called MAXI J1820+070, or J1820 for short. This stellar mass black hole is around 10 times the Sun's mass and funnels gas away from a neighboring star and into a dense ring of material called an accretion disk. Magnetic and gravitational forces compress and heat the gas to millions of degrees, hot enough to glow in X-rays. We think the flare of X-rays NICER spotted was due to an instability in the disk, which caused a flood of material to move toward the central black hole. Above the black hole is a region of subatomic particles called the corona. The corona is extremely hot, 1 billion degrees, and shines in even higher energy X-rays. Not a lot is known about why the corona is so hot. This outburst provides an opportunity for us to study how both the disk and the corona change as the black hole consumes this material. Waves of X-rays from the corona echo off the accretion disk like the sonar we use to explore the ocean floor. These echoes tell us about the size and shape of the disk and corona. Iron atoms in the disk absorb X-rays from the corona and then re-emit them. Gravitational distortion of space-time stretches the wavelengths of the X-rays, reducing their energy. The farther from the black hole they are, the less the light is affected. As we watched the system over weeks, the light echoes got closer together. This suggested that something in the system was becoming smaller. The low energy emission coming from iron atoms close to the black hole didn't change at all, suggesting that it was not the disk moving in, but rather the corona shrinking. The team and I estimated that the corona contracted from roughly 100 miles to only 10. The discovery reveals that stellar mass black holes behave similarly to their supermassive cousins, which are millions to billions of times the Sun's mass. Those monster objects are found in the hearts of most galaxies, like our Milky Way, but their slower evolution over millions or billions of years is impossible to detect on human timescales. Stellar mass black holes, on the other hand, evolve much more quickly. Thanks to NICER, scientists like me are observing the evolution of black hole systems and learning more about how our universe works.